I'm Gerbrand Haasbroek. I'm the Operations Manager Metal at Hulett Aluminium in South Africa. And I'm involved and directly responsible for the operations of 3 remelt facilities on the site, manufacturing melting ingot for the rest of our rolling plant. One of the major products that we produce here is can end, which is 5182 aluminium, which contains up to 5% magnesium. And we were having difficulties with extended periods of melting and adding of the magnesium, having to add up to 5% magnesium in a 65-ton furnace takes quite some time, and we were losing time and we weren't able to supply enough of the 5182 through to our rolling plant. So we were looking at the EMP as a way of introducing the magnesium into the plant without having to open the tending doors. The doors are open for extended period, say 20 minutes or whatever, while the magnesium is being dissolved. We can now introduce the magnesium during the melting cycle, so we don't lose the time, first of all. Secondly, we don't have to open the doors, so we don't lose that energy. So it's improved the energy efficiency as well. The original, like I said, the original idea or reason why we installed the EMP was just to cut down our cycle time to increase our throughput, which we've done, and with an approximate 20% increase in throughput, which we have achieved up to now. But there's other advantages as well, in the sense that we've cut down on the magnesium losses. When tendering it, introducing it through the door, we were losing at least 4% more of the magnesium and burn off on the surface of the metal during this operation. And with the EMP, we've been able to recover those metal units. There's other advantages as well, because when you burn the magnesium, it forms spinels, which are high melting point spinels. And they find their way into the metal and can cause defects. So with the reduced loss of magnesium, we are getting improved product quality as well at the same time. The initial idea was to save the money based on the throughput. So our calculations indicated if we can get a 20% throughput increase, which we achieved, payback would be approximately a year. But with the additional benefit of the savings on magnesium and the quantities of magnesium that we consume, the payback was within months. This specific one is a conventional EMP, and we are now looking at the vortex type. In the other furnaces, we have two lines which are basically identical, both 65-ton top loading, round tilting furnaces. And the other one, we produce quite a variety of alloys, and amongst other alloying elements is silicon. And we believe that the vortex EMP is ideally suited to quickly dissolve the silicon into the metal. So we've decided to install that to get that benefit once again. Yeah, the EMP, the one that we've installed on our line 1, was the first one, as far as I understand. It was installed on a tilting rotary round furnace on the side of it. It obviously had its own inherent problems because it was the first time doing this. It had a tilting moment, because as it tilted, it actually rotated around the tubes. And initially, our structure wasn't stiff enough, and we had slight movement which caused cracks in the tubes. We sorted that out by beefing up the whole installation and the structure. And subsequent to that, we had problems which I think is a normal situation, is having blockages in the tubes. And we resolved that. And now that we've got our procedures sorted out, this system has run effectively for more than 6 months without any stoppage. So we're convinced that we've now overcome all the initial commissioning problems. They've come out and helped us commission, and when we had difficulties, they came out again and sent different guys with different experiences, and everyone has been able to contribute and to help us. But then, at the end of the day, I think we had to bite the bullet, take responsibility ourselves, and actually solve the problems at the end, but using that information they had given us. They were very helpful, no problem.
I'm Eric Schultz. I'm the project manager at Remelt, and the EMP was one of my projects. I've been with it since June 2004. The furnace wasn't designed to have an EMP system, so it's an add-on. So we got to make it fit somehow. So it's not an elegant thing. The problem we had was that the structure was not allowed to twist more than one millimeter, more than 1 mil. So we've actually tested. We put a 10-ton coil on it, and we measured it, and it didn't twist. But there was always a bit of doubt in it. So much so that when it came to design for EMP2, we did it differently. We learned from EMP1. It's a dry hearth. It's a tilting furnace. the bath level in the furnace is very shallow. In fact, only 560 mils. It's very shallow. And being a tilting furnace, the problems are the nip points. There are nip points between the structure of the charge well coming down, being a nip point with the structure with the platform structure. We have got this problem between this furnace being so shallow, the bath level being so shallow, in terms of that level, in terms of with the level of the floor. So where can I put this charge well in terms of height with the bath level? So there is a problem there. The communication was always fairly good. In other words, if I sent them an email or I found them, the response was always there. They've often visited us. I mean, almost every team member has been here. Andy was here, and Mick's been here, Roy Lund's been here, and Gary Evans has been here. He's a typical hands-on man, absolute an extraordinary fella. So I can't say that we had problems with it. They were always there. Yes, absolutely. And if they couldn't answer me, then there was always the lady there, Sue Flynn. That's it. She was always there.
Gus Hornsby. Basically, I'm the quality and process specialist for the remount. We're an aluminium semi-fabricator. We do a range of alloys, probably more than most plants do, and that's actually quite a challenge. We do anything from the 3000 series, 4000, 5000, 6000, some 7000, but not on this site, some 8000, also not here, and 9000 series alloys. Basically, I think Gerbrand and myself, when we had a look at the technology, we decided that this is something we could really use. Our biggest challenge then was basically alloying magnesium. We went through different options of trying to maximize our yield, get improvement in terms of metal quality, etc. And we believed, and I think have proven since, that the choice of an EMP was the correct choice. We were looking at something like an average of about 85% recovery of actually magnesium. We improved recoveries quite significantly when we added magnesium through the EMP. We started off, obviously, a learning curve. We started off with around about 95%, an improvement from 85, which was quite significant in itself, and we were able to do up to 98% plus in some instances. In terms of other issues, the more metallurgical type and metal cleanliness issues, I think we've got a good process anyway, in terms of our metal cleaning operations, if you like. But definitely we've seen in the melting furnace itself a reduced quantity of magnesium oxide, which comes from alloying magnesium, burning and things like that. We've seen a significant reduction in that, the burning on the surface of the melt in the melting furnace. And clearly the benefits of the pump are that the magnesium bar gets submerged almost immediately, and eventually get very good dissolution in the EMP well itself, and eventually pumping it out through the bulk of the bath. And as I said, we've got some techniques which we use, which we can consistently get above 98%. We've had 2 sets of training from EMP. The first lot was one of the commissioning engineers, and then we had more focused process training from Gary Evans. The support we've had from EMP, from the technical side of things and the operation of the equipment, I think has been great. Gary, for example, worked directly with the guys on the floor and showed them that some of the things can be done. Some of our routing cleaning of the legs, for example, it was something which everyone stood back and said, oh no, why do I have to do this? But when he showed them how easy it was and that it actually helped in maintaining the system, it was accepted quite readily by the operators. I interact very closely with the operators, and I've only had positive feedback from them. some of the comments we actually put in one of our local monthly newsletters, and I actually forget what it was, but it was like EMP, my savior, or something like that. Clearly, when we go down, even for maintenance of the system, you know, they come back and say, hey, quickly, when are you getting it back on stream? Because you know, we are now struggling. So that was a very positive thing from the operators, you know.